I want to be able to print all numbers from 0 all the way to infinity. So to do this, I've already written a function. It's called print all numbers. There's an integer I which is equal to 0, and I use a while true loop to print I++. So if I go ahead and compile and run this, you're going to see that it's going to keep printing all numbers. It's not going to stop. Now, let's say I want to do this recursively. I can create a new function. Let's call it print all numbers recursively. It's going to take in a variable n as its input. So really all I have to do is I have to say system.out.println, and it should print n. And then I can call this function for n plus 1. So if I compile this and run it, the first thing is going to be 0. You'll see something interesting happen. So it's gone all the way to 15,481, and then I've gotten an error. Let's see. It's a stack overflow error. What exactly is this error? A stack is a data structure which can hold a collection of elements, and only the topmost element can be accessed. I'm going to represent a stack with some books. So I can add books to this stack, and like I said, only the topmost element can be accessed. So I can only add elements to the top of the stack or remove elements from the top. Now a stack has a limited amount of memory, which means it can only hold a certain number of books or elements. So if I say that the capacity or the number of elements this stack can hold is 6, then I can add up to 6 books to this stack. However, if I try to add a 7th book, what I'm going to get is a stack overflow error, because the stack doesn't have the capacity to let me add another book. So that's what the stack overflow error is.
The reason we're getting the stack overflow error is because of how Java works. Every time a function is called in Java, Java takes that function and all the information associated with it and adds it to something called the call stack. And once that function is completed, it removes it from the call stack. I can in fact show you what's happening by adding this thing called a breakpoint and then running the program. So if I do that, you will actually be able to see the call stack. So right here on the left, I have the call stack. And right now, there's only one function in it. The information associated with it is here. There's an integer n, which is 0. Now, as I continue to run the program by hitting the step button, more functions get stacked in the call stack. You can see all these functions are there on the call stack. And this keeps happening. Like, these functions are not going to get unstacked at any point. So at some point, Java runs out of memory to store all this information and the stack overflows. So that's what's happening here.